Hi everyone, welcome to Ladboy coding. Today, we're going to solve problem 261, graph valid tree. We can see this is not a very common question in the interview, but it has a very important idea, how to detect cycles in the graph. So let's see the questions. Given n nodes and a list of undirected edges, we need to write a function to check whether the edges form a tree. So this is a little bit abstract. Since it's a graph, let's draw it and visualize the graph. So in this graph, we know that we have an edge from 0 to 1, 0 to 2, 0 to 3, and 1 to 4. This is a valid tree because it has no cycles and it has one connected component. And if this is the input, we know we have an edge from 0 to 1, from 1 to 2, 2 to 3, and 1 to 3, and 1 to 4. This is not a valid tree because it has a cycle between 1, 2, and 3. If we remove edges between 1 and 3 and 2 and 3, this is also not a valid tree because it has two connected components. So we need to make sure the graph has no cycles. And we need to make sure the graph has only one connected component. So how do we make sure the graph has only one connected component? This is the easy part. We need to have a visited set. And after we run DFS, we check if the number of nodes in visited set is equal to the number of node n. If it is equal, we know we traverse all the node. Otherwise, we know there are some nodes that we cannot reach given the edges. So yeah. How to detect cycles in a graph? This is the important piece in this algorithm question. So if we have three nodes in a graph, A, B, and C, we run a normal DFS, depth first search. We start from A. Then we know we visited A, and we put A in visited nodes. And then starting from A, we go to B, and we process all the neighbors of B, and then add B into the visited nodes. And when we are processing B's neighbor, we find A again, but A is already visited, so we do not go to A. And we, starting from A, we go to C. Then, starting from C, we can go to A, but A is already visited, so we do not go to A again. So, but what if we have a cycle here? We have an edge between B and C. How do we detect it? By using modified version of depth first search. To put it in one sentence, starting from A to B, and if we find B is already visited and B is not a parent of A, then it has a cycle. So let's write this down. So let's see our algorithm. So first of all, what is a parent? If A goes to B, then we define A is B's parent. and we use an additional data here. And A has no parent. And if we start from A to C, then C also has a parent, A. Yes. And then how do we run this algorithm again to detect cycles? Starting from A, we set C's parent as A and B's parent as A because A goes to C and A goes to B. Then we visited C. Then when we are visiting B, we see that from B to A is already visited and A is B's parent. So we can't prove it has a cycle. But when we're starting from B to C, we know that C is already visited and C is not B's parent. So we find a cycle here. So this is the algorithm. We need to keep an additional parent data when we are doing depth first search. Now let's see our code to put it together. First, indeed, we need to create a graph. Since it's an indirect edges, A, I mean, it is an undirected graph. So if node 0 have an edge to 1, then node 1 also have an edge to 0. Then let's write DFS to detect cycles. And we will use a stack to do DFS. The root node is any node and its parent. Now we start from a 0 and it has no parent, so we put -1. Then we traverse all the node's neighbors. We also need to put it in the visited set. If the next node in the neighbors is not visited, we put it into the stack. and the parent of this node is the current node. So if it is already visited and if it's already visited and its parent is not equals to the visited node, then we return false. So this is how we detect cycles. And after we traverse all the node, we just need to check if the number of visited node is equal to the total number of node. If not equal, we just return false. So let's run our algorithm. Yes. Now let's submit our code. Okay, it's correct. So let's analyze our time complexity. Notice that we need to traverse every element, every edges in the graph. So the time complexity would just be V plus E. V is the number of nodes in the graph, and E is the number of edges in the graph. Yes. Okay. Thank you for watching. The code is in the comment and in the description. If my solution helped you, please feel free to leave a comment and subscribe. Thank you. Bye-bye.